Okay, so this tutorial is going to show you how to take points on your map and begin to visualize it in interesting ways using several density tools. So if you open up this densities package that I give you, you'll see what you got here. Several layers that are pretty useful. The first one is the Metrolink stations across St. Louis. We won't use that now, so just turn it off. The second line here, July 2015. These are all the crime locations for St. Louis in July 2015. And I already, this is the thing I showed you last week in terms of like taking the XY data from the police station website. I just took that data and I re-exported it as its own shape file. So, but it's the same exact information that we used last week. Metro Rail, we won't use that for now. And these are just some base layers. So sidewalk layer, I'm just giving this to you guys for free. This is actually a file that isn't public, so you guys now have a sidewalk layer you can use for your own projects. So you should thank me. I'm giving you straight files that aren't out there, you guys. And then basic roads. And these two layers here I'm going to use later, but the one we want to use right now is this point data right here. So the first thing I'm going to show you guys is how to take this point cloud, this point data here, and turn it into an interesting density map. What I want to do is I want to use the same concept we used previously of joins and relates. So previously we did joins, spatial joins, using these little neighborhood boundaries. And so we chose each boundary and figured out how many points are in each boundary. The only problem with that is that some of these are all oddly shaped boundaries, and you'll always get a map that feels a bit too, it doesn't feel specific to the data itself. It feels specific to this boundary here. But what we want to do is we want to take these points here and then map them true to its spatial location. And so the only way we do that is to actually create our own grid of parcels. So I'm going to show you a tool called Fishnet. So again, the easiest way to find any tool is not like digging through this list of tools here, but simply just searching for it in the search command here. And you can just find that by clicking up here in the little search bar. So type in the search bar Fishnet. And what is Fishnet? Fishnet is a fishnet. Create Fishnet. A fishnet is a net. And the first thing you want to do is you want to select the output feature class. So all you need to do is basically click that folder. Okay, so I'll just call this. Just select this guy. And let's call it Fishnet. Save. Actually, it should go in here. Save it as Fishnet. Always make sure you save it inside the geodatabase. So usually in your documents folder, you have a default GBD, and just save it in there. And then what you need to do is set a template extent. And that is basically just going to be the point cloud information here. So just find that layer, that's the July 2015 layer, and just select that right there. And it's automatically going to fill in some information about the extents of this fishnet. The next thing we want to do is we want to set the width and height of each cell. So before doing anything else, we need to kind of understand what size of a grid we want. And the easiest way, in my opinion, is just to take the measure tool here. Make sure you know what your units are before you do anything else. We're working in feet. Just click no. And just kind of see, like we say we want a box about that big. That's about 1,000 feet. Let's make it a bit smaller. Let's make it like, let's do a 300 by 300 grid. So cell size width will be 300, and it's going to be feet because our units are feet, 300. And as you can see, the number of rows and columns disappears as a required field because once you have the extents and the size of the cells, it automatically knows how big it's going to be. And I uncheck this box here, create label points. That just creates an extra layer that's useless for our purposes. And then also make sure that the geometry type down here is a polygon. So polygon, you can calculate area. Click OK. It's going to create Fishnet. And you see what now basically you have here is a grid of shapefiles. These are basically the same logic as your neighborhood parcels, except now they're a bit more fine-grained detail. So now you can actually represent your density in a way that's a bit more precise and a bit more visually interesting. So now from this point, we're going to do the same exact thing we did last week, which is use the joins and relates tool to calculate the number of points in each one of these cells. And as you can see, because these are so small, it's going to have a lot more fine-grained detail because the difference between one and the other is going to be a lot more precise. 2 points, 1 point. Some will have 3 points. I'll show you what that looks like. So again, you guys know how to do this already. Go to Fishnet, new file we just made. Join. Spatial join. And we're going to use the July 2015 as the data we wanted to link. And make sure you click sum. So it's going to add all the points in the file. And then you can select location. I'm not going to bother picking location just for the sake of this tutorial, but let's just call this Fishnet crime, which makes no sense because Fishnet crime is a... Okay. It's Fishnet crime, all the fishnets being stolen in St. Louis. This is a huge criminal justice issue. Where would we be with all these fishnets that are being stolen? Okay. That was a joke and no one laughed. Again, one day I will make you guys laugh out loud in laughter. Anyway, this fishnet crime here, as you can see in the attribute table, we have some layers, some count. Should have the sum count. So a lot of these don't actually have any information because the points didn't overlap with anything. So that's why there are some nulls here. But let's just visualize this as a chloropeth gradient first. So actually, double click this. Go to quantities, sum count. Let's do a blue to red. So you see red is dense and blue is no crime. Let's give it like 20 classes. Actually, since there's 16, let's do like 10 or something in between, like 12. Okay. Apply. Actually, haha, we're back. Everything is going fine. All right. Another thing you can do is now that each circle has a value to it, you can actually add proportional symbols. So let's do sum counts again, and let's just click apply and see what happens. And see, this is actually pretty interesting. Is you can actually map icons, and they are all scaled proportionally. So this is a new way basically to map your crime data using this symbology tab here. And it's kind of cool. Is what you can do is let's get rid of the background. Let's get rid of the make these no colors. Let's actually make the symbol like your classic plus that everyone at the GSD likes to do, because people at Harvard just make pluses all day. Let's just make them red or something. Okay. And now you've made a pretty interesting looking map that takes the crime data that we had previously. Let's turn this on right here. And begins just to organize it and make it spatial in a bit more of an interesting way. So you see, it's not just dots, but now the dots have scale to them, and now everything feels a lot more of an interesting pattern. You can begin to understand like locations and patterns of things a lot more interesting. So a lot of you guys who use point information to visualize maps, this is a good way to do that.